All right, we can get started. Want to start off by thanking everyone here for joining. We got a couple of people that will be talking here. I'll be starting this off. My name is Sean Verbout, working with Next Gen Solutions, help with the mold flow and helping people with technical questions. Actually, the questions on the sales side of things for it and business development on mold flow for Next Gen. And then also Umair will be talking. He's the technical expert on mold flow. So if you guys have any questions throughout, you can ask during the live session here in the chat. If not, it's recorded and we'll be posting this online as well. So again, I appreciate everything. I'm going to start this off with the kind of introduction of what we'll be presenting, and then we'll kick it over to Mayor. He'll be doing more of the technical discussion, and then I'll wrap it up at the end again as well. We'll try to keep this pretty tight to an hour, if not a little bit shorter. So with that, we'll get going with the agenda. So we're going to go over, I know a lot of people on here may be new to Moldflow, others are very experienced. That's kind of what I have seen through a lot of the customers that I've been working with. So we'll kind of, try to hit the full spectrum here. With this presentation, we'll go over what is Moldflow for the newbies out there. And then we'll go into injection molding, the intro and troubleshooting. That it will be Umair taking that over. And then we'll kick it back over to me, and I'll kind of go over a couple of the customer experiences that I've seen and how Moldflow has helped them to really increase the return on investments and helping their business situations out. And then the Moldflow packaging and upcoming changes with Moldflow, which are, there's some pretty big changes, but the changes are going to be really good for you guys, the customer, and is just managing the licenses. And also I think on the dollar amount side too. So it's the finances. So that'll be good for everyone. Next, Umair. So what is Moldflow? For the most part, Moldflow, it's been around for a while. It's the largest market share out there for molding, and it's the most mature technology out there. So what we've seen is that it's been around since 1978. So basically it reduces the risk by giving, the customer that knowledge or insight into the design and manufacturing process. And it does it virtually before the mold's created. That's important because it really saves those front end costs. So we'll explain that as we go through the slides. But if there's a molding that's taking place, and you go through the process and there's a kind of a fault in there or some kind of imperfection, that could cost anywhere from $10,000 to up to $100,000 depending on what you're molding. It's estimated that 80% of all plastic parts produced are injection molded. There are other molding processes out there, but the vast majority is injection molding. Next. Common reasons customers buy Moldflow. These are all the ones on your screen there that we've seen, but the return on investment for these especially is the rework, the reduced tooling and the mold costs. As I just mentioned previously, we're able to find those defects on the front end of the process. So you're not spitting out parts that have defects in them, and then your customers that you guys have to answer to aren't upset. And then also the time to market is a lot better, knowing that we're able to get those quirks and tweaks out of the way up front. The material savings times, fast return on investment, the savings, especially with the scrap. So we're able to use the materials in a very efficient way to reduce some of that waste as the material goes through and that product goes through your system. Next slide, please. All these are the benefits. This is kind of like a half wheel here of from product design on the front end to kicking that product out to your customers or that part. All these are the benefits and what Moldflow can bring to your business. The ones I start here are the ones that I've seen really where Moldflow makes your business sing. So improves on the front end product creation and reduces that environmental impact. That's a very hot topic right now, obviously. reducing that environmental impact by not having that waste on material, really utilizing the most material that you can on the front end, and that helps your profitability as well. To improve the profitability on the business growth, increase the market share, you're able to spit out more products in a quicker fashion, and then reducing the defects and the nonconformities, as we mentioned before, by having that Moldflow, especially the Moldflow Inside, having those capabilities and making them sing on that front end. Next slide, please.
Awesome, thanks, Sean. I'll take it from here. So again, just to reiterate a lot of the things that we already kind of talked about, but we all come from that environment where we understand that, time is money and everything affects your business in so many different ways. For example, reworking with molds. So reworking molds are one of the most expensive ways to scrap a project, or for example, if we didn't look ahead and see if we simulated things properly just to make sure that we don't have issues with our molds, right? We need to make sure that we can reduce a lot of that rework going back and forth between a vendor or between your manufacturers for those certain molds, or even if you're doing your molds in-house, right? So if you have if you have CNC manufacturers in-house, how can we get ahead of this issue by reducing the amount of rework that we do on our molds? Every time it comes off the press and goes back into the press, we're dealing with a lot of time and money, right? So how do we get ahead of that? Next thing is waste, right? Especially in modern days, a lot of interest and a lot of research is being put towards how to eliminate a lot of this plastic waste that's affecting our environment. So how could we possibly use multitudes of different sort of materials, things that can be recycled, things that can be recycled? Will it work for this specific purpose? Can we save time and money? Instead of actually having to research in the press to make sure that the material works, can we get away from that and you do it all through simulation, see if that works a bit better for us? Next thing is our process, right? Our process settings, especially on all the different types of machine models that are out there for injection molding. Certain materials deal with the very different types of process parameters, right? So we want to make sure that whatever material that we're buying, we're spending money on that material. We want to make sure that we're treating that material properly, running that material at optimum temperatures and optimum flow rates and such and such. So all this, again, can be handled through Moldflow. Next thing, like I said, material is, so Moldflow has almost 10,000 plus material database information, and it's the biggest database that's out there currently for any sort of simulation software, meaning you have access and trials to simulate your part using so many different thousands of materials to make sure that, again, you're using the right material for the right fit, and so that your part is fully functional, but also we are saving time and money by not using too much expensive materials. Time, right? Again, biggest thing that impacts your business at the end of the day would be the amount of time that you're actually running these parts. We want to reduce downtime of your presses. Major things are your defects. We want to reduce a lot of the defects that come out from your parts, especially when it comes out of the press. How can we improve the aesthetics of our parts, right? Especially with, again, modern designs, we see a lot of plastic components now becoming very organic, becoming very almost futuristic. So we're dealing with a lot of curves. Things are reduced. The amount of sharp corners and boxes are being reduced now. So I know designers are out there, creating so many different types of good-looking parts, but we also want to make sure that these parts can actually be manufactured, right? Just because they look good doesn't mean they're also going to be able to manufacture properly. So we want to make sure that when we simulate it, the parts are able to actually come out of your press. And we'll also take a look at, how can we reduce a lot of the failures that we see with modern day injection molding processes, and kind of see how Moldflow fits into your workflow and your business and how it can help improve communication between process engineers, the design engineers, the manufacturers on the floor, right? How can we improve that communication without a lot of back and forth, especially with different part iterations and such and such. Okay, so that's kind of where these are some of the major categories that Moldflow can really step in and help you and your business. Kind of what I talked about earlier, like so currently a lot of the challenges in manufacturing is time to market is critical, right? As soon as we have an idea pop up or as soon as we have a CAD model that's ready to go, from that time to actually production to shipping, that's going to be where you see the biggest time drawback before its payout period. So we want to make sure that we get ahead of any sort of issues that we see during that time period. Try to reduce the amount of iterations, trying to reduce the amount of time that your parts will take to be manufactured. Again, part defects, we talked about that. Very costly to your business, and then we can also we can better forecast production and shipping, so that we can reduce those sort of delays from that point of view. Thousands of materials again, right? Like I said, we want to make sure that we're using the ideal material. And also, how do we work between each other when we're all stationed in different, we are all geographically distributed in modern, companies and stuff. So how can we have our engineers work with process engineers at the plant a little bit better? So what Moldflow actually does, again, I said, is it focus on the design's manufacturability, right? When we start to design things, again, we're not thinking in long terms of how it's actually manufactured. We're trying to see if things are actually, if that part will work. So sometimes they don't go hand in hand. At first, we have to make sure that the part works for the function that we're trying to do. And then we try to make sure if it's, and then we'll probably even try to run a prototype, and then see if it actually works or not. So, and that can be a costly issue, right? So we want to reduce the amount of times we're doing iterations by optimizing our designs right at the get-go, right? Again, a lot of the same thing. Again, I'm just kind of repeating it, but it's just to make sure that we're using a very efficient way to get to our final product, right? So just to give you a little bit of, information on, again, if you've never heard about what injection molding is, pretty much everything you see around you, any plastic part that you see around you in today's modern day, it's probably injection molded. Like Sean was saying, 80% of the parts today that we're making are injection molded, right? Again, why is it injection molded? Because it's faster, it's cheaper, and it's also built for mass scale manufacturability, right? But to get to that point, again, we have to get through a lot of the initial defects, initial issues that we're having, right? So as a modern injection molding machine, it's actually a very simple process if you think about it from a physical standpoint. You're just taking big batches of pellet material. You're warming them down. Everybody here knows plastic melts, right? So we're just warming it down, and we're basically having plastic do what we're telling it to do. So we're going to inject warm pressurized plastic into these mold cavities, and soon after it's been pushed in, we're going to have a cooling process that's going to happen, and soon after the cooling process is over, then we're going to have part ejection. Do have like a little video here that'll kind of help you to visualize that, right? So as you can see right now, this is just our mold and the cavity. So we typically have a male and a female of our cavity, right? So these are what a current injection molding machine kind of looks like. Here we have the hopper and the plastic granulates. As you can see, it just falls in. And then these heating elements will basically warm up your plastic pellets. And the 3-zone screws pretty much will move all those plastic pellets from the hopper through the heating elements into our actual mold and our press, right? So as you can see, it's a fairly straightforward process, heating and then pushing it right through the tube into our cavities. Here's a cross-sectional view of that. So as you can see, we also have our coolant bores in there. So the coolant bores, again, like I said, is what controls a lot of the cooling that runs through our mold cavities. As you can see, even on this cross section, we are dealing with a lot of draft, a lot of thin walls, thick walls, a lot of variation in there too. So as you can see, soon after the part is all the plastic material is pushed into the cavity, fills up that cavity, and then holds it there to make sure we have packing pressure. The cooling process works through, and then as you can see, the mold opens, and then we have our plastic part ejected, right? So that's just a simple explanation of what modern day injection molding kind of does, right? So with this injection molding comes the problems that we typically see in a lot of different parts and a lot of different materials. So voids and bubbles, as you can assume, those are places and areas where air probably was trapped and the plastic couldn't completely fill into that zone. Next thing we see weld lines. Weld lines typically happen when we have multiple different flowing plastic that then fuses together inside of the mold. Now, again, this might not be easy to always kind of predict and control. However, that's why we use simulation software like Moldflow, because now we can better build and design our own molds, our cavities, to make sure that the flow of plastic within our cavities are much more uniform, trying to reduce a lot of those weld lines, right? Next thing we have, the big one is sink marks. Sink marks happen again when there is uneven filling, and then also when we have rapid changes in our cooling and heating temperatures, which can cause certain vacuums within our plastic and then causing those sink marks. Warpage and shrinkage is one of the biggest ones again out there that kind of affect a lot of modern day parts, especially when we're trying to make parts thinner. Because of its geometry and because of the way the fibers may be orientated inside of our flow, we might see twists and turns within our material. And then with temperature changes, or even we've seen issues with moisture, we could see our parts starting to bend because we don't have proper fiber orientation when we eject our parts. So again, Moldflow, Autodesk Moldflow can help us with this by kind of seeing how different materials work with different fiber orientations and select materials that will have better fiber orientation to help us reduce the amount of warpage and shrinkage. Again, we have the next few things are the burn mark from air traps, right? So for example, if we have air traps within our mold, high temperatures can build up within the certain segments, leading to burn marks. Next thing is our short shot. Again, a short shot is when we don't have enough plastic being pushed into those areas for, again, maybe we have either uniform flows, or we just have poor design and we have probably thin walls that lead to a lot of resistance so that plastic can actually be filled in there. So we can, so these are some of the most common molding issues that we see today. So how do we get by this, right? So what does Moldflow offer in order to help us get through all of this type of issues? So pretty much what we have is we can simulate our flow of plastic within our cavities, and after we simulate that flow within all of these cavities, given your materials, we can kind of see and find out where some of the biggest issues are happening. What are those issues, right? So for example, trying to solve common issues with the biggest ones, like I said earlier, would be race tracking, hesitation. So race tracking again is, non-uniform flows within your cavity. Hesitation is when you have the differences between probably thin walls or thick walls. Think of it as, when you're trying to push material inside certain features, depending on if it's thicker or if it's thinner, plastic is always going to go with the area that has least resistance, right? So in situations like that, you're going to start to see a lot of the plastic go towards the thick areas versus the thin areas, and you're going to have issues with hesitation there, possibly leading to air traps, issues with venting, and all of this kind of waterfalls. And then you're going to see weld line issues where, again, non-uniform flow rate will cause all these issues. So this is how simulation up ahead can really help identify where these issues are occurring, what type of issues are occurring, because sometimes you might get all of this right, but it might not be even an issue with the plastic. It could be an issue with the process parameters, like I discussed earlier, improper temperatures, improper feed rates. All of this can lead to all of these types of different issues, and it doesn't mean that you always have to redesign your mold. It could just be maybe tweaking those parameter settings, right? Next thing is it'll also help evaluate your part design, right? So when we talk about part design, we're not really concentrating on material and the actual injection molding process, but your cavities and the end geometry of your parts. So if you have parts that have thicker wall thicknesses or thinner wall thicknesses, really high draft angles, or certain areas where you don't even have a single draft angle, we can have issues with plastic flowing into those areas. So what the simulation will do is it'll identify and it'll show us exactly, for example, like in this area right here, as you can see at the bottom, it shows that we're having issues with trying to push plastic into these areas. So what are our options? So what's also nice about Moldflow, depending on the package you get, Advisor or Inside, we can get more in-depth information, and it'll suggest certain improvements to your designs. So you can bring your CAD data into a different software, for example, where you actually do your design, improve those features. Maybe we need to add a few ribs. Maybe we need to add increase our wall thicknesses and things of that nature to help create better parts that will be ejected out of your mold without too much issues. Here I have just a simple graphic to kind of show you how we can validate our part performance, right? So if we follow things from our initial stage where we just have CAD models, there's two ways that you can run simulation on your CAD models. At first, we could just do structural simulation. Now you could use a different sort of software for that. But Autodesk Moldflow is really mostly for a process simulation, meaning we're only studying the flow of the plastic and not the actual, some may say FEA characteristics that you would find from your parts, right? We're not actually doing structural simulation. We're doing mostly flow simulation to make sure that our injection molding process will run smoothly, right? So how all this ties in together is you can run Autodesk Moldflow simulation separate from your structural simulation to make sure that you have proper manufacturability. After we make sure that we have proper manufacturability, we can now tie this portion of the simulation or portion of the study into structural simulation as well to make sure that then you have 100% proof. Well, let me take that back. I don't want to say 100% proof because you know what? Sometimes anything can happen in manufacturing workspace. So at least let me say you have a favorable amount of understanding and confirmation that your part, at least in theory, will simulate well from the flow workspace and also from structural characteristics as well. So that's kind of how Autodesk Moldflow will fit into your business's workflow. Use it at the inception, or at least use it through the midway life of your CAD design to make sure while you keep designing that your part is still in peak manufacturability. Next thing is, again, this kind of will concentrate more on the parameter stuff. So this might be different for different customers, depending on the different machines that they have, and depending on the different sort of materials they're using. But Moldflow Advisor and Inside, both solutions will offer, excuse me, will offer really good default or starting point parameter suggestions. So for example, like if you were running ABS plastics or PLA plastics or other different sort of polymers, the information as far as recommended mold temperatures, right? Melt temperatures and even feed rates and pressure parameters will be suggested to you. Now, this can be tweaked, obviously, depending on the peak optimization values. But what Moldflow will do is it'll give you a lot of windows and it'll give you graphical representation to say, hey, we've given the history of this material or just researched values, the ideal parameter settings for your injection mold machines will reside within these certain spaces. And that's kind of where you, again, end up saving a lot of time and energy. So instead of doing all that research yourself or going back and forth with vendors for different materials, all of this information is readily available to you. And it gives you good start and stop points so that you can decide, hey, maybe I can try to push the feed rate a little bit higher, but I might also have to maybe increase the mold temperature just by a little bit to make it easier to push that plastic through into certain features. So it really gives you the ability to get creative with trying to find that optimal window for your simulation and how you want to run the certain polymer inside of your injection mold machine. Just to touch on, again, like I said, the material database on Moldflow, Autodesk Moldflow really is what sets it apart from a lot of the other simulation software out there. Having the ability to simulate over 10,000 grades of plastic really, again, gives you the freedom to be creative on how you want to, find the right balance between cost effectiveness, but also maintaining your parts' functional structural capabilities, right? So it also gives you material quality indicators. It also gives you energy usage indicators. So if you're looking, and a lot of these symbols kind of will show you that this certain polymer has this level of effective energy use, and also kind of will show you some information as far as recyclability. So meaning you can also be sure that maybe you can have your parts be created or be manufactured with certain polymers that are good for the environment, or again, just trying to be cost effective. And if you are able to buy this plastic at cheaper rates, if you have good recyclability, right? So just a little bit of information that will be provided to you alongside all of the material that's offered for simulation. So ultimately, we have two major products with Autodesk Moldflow. We have Moldflow Advisor, and then we also have Moldflow Inside. So Moldflow Advisor basically will cover a lot of the major components as far as simulation goes for your studies. So it can do a lot of things as far as wall thicknesses, undercuts. Like I said earlier, it also has design advisor capabilities to it. So if you're kind of stuck and trying to figure out why I'm having so many issues in that one certain point, we could run the design advisor to make sure that it can tell us if we increase the thicknesses, for example, in this certain area, it'll really help the plastic to flow a little bit better. It can also catch draft angles too steep or things like that. Also kind of give you the optimum locations for gates and filling. You can run multiple studies to make sure we can also you have really good flow sites. And also we can figure out what are the best runner balances and sizing for if we're running multiple cavities of our mold. The next thing, the higher or the advanced version of Advisor would be called Moldflow Inside. Moldflow Inside will include all of Advisor's capabilities, but also some additional, much more highly advanced components. For example, the advanced heating and cooling. We have a lot of customers who kind of use that component just to save a lot of time trying to figure out where the parameters lie for the cooling and heating. And then some of the other ones, again, would be the shrinkage and warpage prediction. Like I said earlier, it's a very common issue, an issue that a lot of people see with their plastic parts. So using the shrinkage and warpage prediction really helps people in the long term as far as an investment is concerned. So like I said earlier, Inside would be the more advanced version of Advisor. I know Sean likes to always call it the Cadillac version of Advisor, and most probably would if we see a lot of our customers say that they're not seeing a lot of the solutions that they would like to see based off of Advisor, we would always tell them that Inside will probably be able to give them a better success rate at finding those issues with the simulation. Just to kind of wrap up, and why would you select Autodesk products, right? So Autodesk has been around for almost plus 44 years. It's got a thriving user community. Typically if you have any sort of issue that maybe you can't contact support almost immediately, you'll find so many different forums. To be honest, I've been on there and talked to people in the field and with similar experiences, similar expertise, and you can pretty much get answers for whatever you're looking for just based off of this really big thriving community. And also the connection that you get to a lot of these industry experts who've worked in the Moldflow area for eons would be the word. And then technology, right? Because Autodesk has a large family of products, you can also make sure that if you're using other Autodesk products alongside Moldflow Advisor, you have that interconnectivity between a lot of the products, right? For example, you can get connections between Fusion 360, which is their new up and coming leading CAD workspace as well. So if you needed to move your product from Advisor into the CAD workspace, make those changes in Fusion 360, bring it back, tie everything in together. So now you're having a full family of Autodesk products at your workspace, kind of help keep things a little bit more uniform, better productivity, again, better interconnection at your business as well. With that, I think Sean's going to go over and try to find out if Moldflow is the right fit for you. And yep, thanks to everybody for listening on about the technology part of it. Sean, take it away.
Yeah, thanks, Umair. Yeah, so Umair touched on everybody that uses Moldflow, that was very beneficial. I'll be talking now with the people that are signing up on the POs and writing the checks for the software itself, and then identifying if it is a good fit for you. So the next slide, please, Umair. Is it a good fit for you? So like I said, who all is listening to this might be somebody with 30 years experience with Moldflow. It might be a company looking to dabble in it from the start, very beginner. So if you do injection molding, yes, it's going to be a good fit for you, but there's also compression molding, the transfer molding. I know there's some customers that I work with do the LSR. If you have a new product line coming out, if you're worried about really identifying the defects, definitely reach out to one of us or Umair, and we'll see if it can work for you. If you have problems with existing products, which I have seen here just relatively recently, where a customer was working on a project for a year or two, and they couldn't quite figure out how to get this part out. Definitely you could use Insight for some of those very, very unique situations. Next slide, please. So why Moldflow? The biggest one is the return on investment, the saving the cost. Typical mold cost, just from the research that Autodesk has done, is between $10,000 and $100,000 each, just for the production of a mold. And some of those very large ones, I've seen some huge ones, over $1 million. So getting that right up front is really the point of Insight in helping the businesses figure that out on the upfront costs. The arrows below there, those are the questions that, if you talk to me or Umair or anybody at Next Gen Solutions, those are some of the questions that we are going to ask you, but also probably ask yourself within your business and in your units, because we're going to ask you, how many projects do you use or do? How many molds do you do? Do you want to minimize iterations, minimize defects? Do you have a challenging material that you're working with? What if we said, we could reduce or cut your iterations down by 1 or 2? If on the lower end, that's, $10,000 per iteration, that's $20,000. That right there, the return on investment, you already purchased the software for saving that. But a lot of it is even decrease the iterations even more. And are you looking to decrease your scrap rate? So those are the questions that we ask you that we will help you. And maybe it isn't a good fit for you. If it's not a good fit for you, that's fine. But we will help you at least walk through that process and help identify if it is. Next. So the Moldflow packaging and customer experiences. This is a fun one. I'm excited about this. Autodesk is changing its packaging of Moldflow. I think it's very beneficial for the customer and advantageous for them on the financial side of it. So before I get into the slides, I think just if you kind of a 30,000 foot view on this, if you were afraid of the costs of Moldflow before, I think this different packaging is going to allow customers that were kind of scared off of the price, they're going to be able to get into a lower price point and use the software. And you're also going to be able to pick and choose when you want to use it. And I think it's going to be pretty exciting here. And a lot of these changes will be taking place here in the end of this year and into next year. But for more information on that, just reach out and give us a shout. Next slide, please. So I won't touch on this too much, but for the most part, as Umair mentioned a couple times, and I have mentioned several times already, there's Moldflow Advisor and Moldflow Insight. More or less, the advisor is kind of the upfront quick analysis, and it also helps you reduce the rework. Insight is more the Cadillac, right? It's going to do the very intricate type stuff. We're going to do even the micro and nano molding, rapid heating, cooling. So it just allows you to do more things with the software and help your business solutions out. Next slide. So the Moldflow solutions, the software right now, and again, this is going to be changing. And I'll just give you kind of a heads up about that right now. There's Premium, Ultimate, so Advisor Premium, Advisor Ultimate. There's Insight Premium, Standard, Ultimate. That's going to be going to more of a kind of just Premium or Advisor with like a Fusion with Advisor, or it's going to be just Moldflow Inside. So more details will come on that. Like I said, if you have any questions, feel free to reach out. But right now, those are the packages, and we have the synergy that goes along with the Insight. We do offer training. There's Moldflow Essentials, their 3-day course, the virtual, and then also the advanced 2-day course that we offer here at Next Gen Solutions. And Umair is a big part of that. Next. Case studies, this is something fun I like to do. I don't use any names here, but this is kind of what I've came across. Customer A, in this particular solution, we try to help people out. And like I said, if it's not a Moldflow and a good fit for you, that's fine, but we're going to try to help you out and point you in the right direction of whatever you can do to become more efficient in your system. So this particular customer has Advisor, the lower end of the Moldflow. They work in the medical device area in the hearing aids. They had a challenging product, a challenging solution. And in that particular case, going up to the Moldflow Inside, because they're working with more of a nanotechnology or nano molding system to identify the molding material and kind of how it was working. So that's interesting. So I think in this particular case, if you do have Advisor and you're having some problems or you need to do something that's a little more intricate, that's where you got to bump up to the Insight. And Autodesk has some great solutions for that coming up in August as well, to kind of use the token so you go in and out of the software. Customer B currently outsourcing all their molding. I talked to them. They would really like to bring that molding in-house because of the costs rising for them, and they were going to start doing more projects, so just advantageous for them. So lowering the outsourcing costs and giving them more control over their time to market was very beneficial to them. And in that situation, it's more of a training opportunity, and also giving them the software and helping them along from the initial start phase all the way to becoming more experts in the software. So that's kind of a cool scenario. Customer C that I've worked with, different molding software they were using. They did have a fewer material database. So in this particular case, for them to go to Moldflow and have that access to the more material database, the 10,000 materials, it really helped them help identify the materials and help them not outsourcing and identifying what materials they need to use for their parts. So it helped them the time to market and provide them a better ROI by helping them identify the material quicker and a better solution for them. Next slide, please. The Moldflow changes in packaging. So this is something where I think there's going to be a lot of talk and a lot of questions around this. Autodesk is going to be going to more of a named user for their software. It's kind of the business plan that they've had for quite some time now. Over the last several years, I've worked alongside Autodesk. So it'll be more of a kind of a named user, kind of going away from the multi-user, but there are a ton of different options out there. I don't think in this particular case there's going to be a one size fits all. So there's going to be various solutions, and I think working through that is going to be fun. And I think it will get in our businesses and our customers the right fit for them. Changes to Insight and Advisor. It's going to be a premium and ultimate packaging will be going away. It'll be as I hear right now, Fusion 360 with Advisor will be an option, and also Moldflow Inside. So with that Fusion platform, and the good thing about that is you'll also be able to use possibly some tokens. So you're going to go in and out of the software, able to do run more simulations. If you're using 1 or 2 simulations, but you need to bump up to 4 to 5 simulations at a time, you can have that flexibility to go in and out of the software, have more users, less users, depending on your business case and your situation. But if you do have any questions on any of this stuff, please feel free to reach out to either myself or Umair. I was going to put my phone number on here, but I didn't, and Umair's. But you have our information, or just shoot us an email. You can reach out to us. So I think that's it for the most part. Is there another slide, Umair? Yep. Yeah, again, please feel free to reach out. There are changes taking place. Like I said, in August is the start of it. So we will be helping anybody that works with Moldflow. And even if you're working with another particular vendor or reseller and you do have questions, definitely feel free to reach out. I can give you, and at least point you in the direction, and see what I can do and help you along. I appreciate everybody. Anybody have any questions?
No, I was going to unmute myself and just say, if you have questions, you can submit them through the Q&A section at the bottom of your screen controls.
Okay. We're happy to also just, maybe show you guys a demo or things like that with the in software. I want to do a little bit of a demo today, but unfortunately we couldn't get it set up in time. But again, it does take a while to kind of show you all of the features that are available in the simulation software. And I think if you spend probably like an hour with us, we can go through even sample parts that you're probably trying to, thinking of like, hey, maybe let's give these guys a part, see what they can do with it, see what sort of simulation studies we can run on it, what are the issues. So we're happy to do that. Maybe like set up a demo or something. Please get in touch with a customer service specialist or one of our business managers, and they'll point me in the direction.
Right.
And I'm happy to spend some time with you guys and probably do a demo. So yeah.
All right. I think with no questions, we can end it there. A little bit short of an hour. So perfect. We're on time. So, all right. Thank you, Umair. Appreciate it, man.
Thanks, Sean. Thanks for coming, everybody. Again, we'll see you on the next webinar series, hopefully.